Newton's second law of motion. Newton's first law of motion talks about the inertia of body, whereas second law of motion talks about how to measure force and what parameter basically play a role to measure force. Let us see an example. If there is a body of mass m which is presented in vacuum, consider there is no air resistance, there is no gravitational force, it's just an empty space and moving with the velocity v1. And that means this ball is possessing initially a momentum called mv1. Now, if you want to change the momentum, there are two options. First option is either we have to change the magnitude of momentum or we have to change the direction of momentum. Let us talk about first change in magnitude of momentum. Again, to understand this, let us assume that mass of the body remains constant throughout the journey. That means if you want to change the momentum, you have only one option to change its magnitude, that is to change its velocity, either by increasing its velocity or by decreasing its velocity, since we have considered mass of the particle remains constant. If I want to increase the velocity or to decrease the velocity, some external agency should act on it, either by supporting in the direction of motion or in the opposing in the direction of motion. If that external agency is supporting the motion of the ball, then the velocity of the ball will increases after a period of time, definitely, because since that external agency is supporting the motion of the ball, therefore the velocity increases. This period we call it as it has undergone acceleration. When the velocity of the ball increases, then definitely the momentum of the ball also increases, because mass was constant but velocity increases in terms of magnitude. Therefore the total momentum of the ball increased in terms of magnitude. But here we need to understand one point. To increase the magnitude, which has helped us? Definitely the external agency. Without influence of external agency, the ball would have not increased its own velocity, right? That is what even first law tells about. Any object cannot change its motion or direction on its own because of the inertia. So definitely there must be an external support required. Let us talk about change in direction. Just imagine a ball is moving in a circular path, or a ball was whirled in a circular path with the help of a thread. Let the ball of mass m and speed of the ball, let it be v. The magnitude of velocity is v, but the direction of velocity at any point will be tangent. And next second the ball would have come here, then the direction will be tangent at that point. That means the direction of velocity change. But here we need to keenly observe that the direction of velocity has not changed on its own. Some external agency has applied on it. Because of that, the direction of velocity changed. Here mass remains constant, but direction of velocity changed. Definitely the momentum of the particle changed. Here also that external force only is responsible to change the momentum of a body. That external force is nothing but the tensional force which is acting in the string. So the tensional force is the responsible here, or the force which is being applied through the string is responsible to change the direction of the body, by that to change the momentum of the body. So here in both the cases we understood to change the momentum some external influence is required, and that external influence only can change the momentum of the body. So from this we can say that Newton's second law is nothing but the rate of change of momentum is directly proportional to force applied and acts along the direction of force. Let us see that. The rate of change of momentum of a body is directly proportional to the force applied and acts in the direction of force. So who is the responsible to change the momentum? Obviously an external force or an external agency. Internal forces cannot change the momentum of the body. So only external force do so.